Assalamu alaikum. Good evening, everyone. How are y'all, children? How are y'all? Good.
It's good. Yes.
So there are new students for today's session, right? So At the meantime, if you have any doubt while studying or you have to clarify something with me, you can leave a message to the co-host, right? Please don't send it to the host because I will not be seeing it, right? Send it to the co-host, right? So let me introduce myself. So I'm Miss Fatima, right? So today we will be starting a free session will be happening today, right? So before that, let me introduce the classes which I am doing and how to purchase it, and then we'll start it, right? If any of your friend is struggling with this lesson, share the link with them and ask them to join, children. This would be helpful for them as well, right? So when you visit the website WebTutor online, okay, you can see my account, right? Under that, if you move down, you can see my classes which I am conducting, right? You can join for grade 11 theory class, grade 10 class, and the past paper class is happening, right? So if you wanted to purchase any of this class, you can make the payment through a online payment is available. You can make the payment through a credit card or a debit card, or else you can pay it, you can deposit the payment as well, right? So you can get the unlimited recording, right? You will be receiving all the recording and which will not be expired at all, okay? You can watch it whenever you want, and we will be happening, there will be exams happening all the time, and here all the recordings are available. You can watch it, you can have some trial classes as well, and then you can continue, right? So that is all about that I wanted to tell you all. And if you all have any doubt, you can leave a message to the chat to the co-host, then I will be replying to you all. Okay, so we'll start the class, right? We'll start the class. So today we are going to talk about the quantification of elements and compound, right? Quantification of elements and compound. So this is the lesson that we are going to talk for today, right? So this lesson is a chemistry lesson. You know your O-level syllabus is being classified into three main topics as biology, chemistry, physics, right? So this lesson falls under chemistry. Now, if I wanted to tell you a method of studying chemistry, how to study, right? If you have a question, how to study, I would say you have to understand the concept. You have to understand the concept. You have to understand how this chemical reaction is taking place, how it is happening. Then if you understand the concept, you can apply to all the questions that you get, right? So normally what people do, what students do in this lesson, they memorize stuff. Don't memorize it, children. Understand what is happening, how is it happening, then you can apply to any of the equation or any of the question that they approach from this lesson. So the main topic what you have to understand is to how to learn and understand the concept and how to do question relevant to that, right? So today I will be giving you a complete idea on this lesson, and at the end of the day you will be clear with this lesson. I hope that it would happen, right? For that, you should be interactive with me. If I ask a question, the answers you all should give me, right? You all have to reply to my question. You all have to talk to me. You all have to be interactive. That is where you will learn in a better way. Okay, so when you leave this class, you should have a good idea, a better idea actually, the idea which you had before, and now it should be developed and improved. So that is what I need from this class. Okay. So we'll start. Now, all about chemistry, what you learned about matter, right? What is a matter, children? Matter is a thing which can occupy space and which has a mass. That's a simple idea of matter. So matter, or you can call it as a substance, right? Now, substance are made out of what? Substance or matter are made out of what, children? So if I wanted to tell, okay, very good, that is atom, right? Matter or a substance is made out of atom. So atoms are what? Atoms are tiny particles. Atoms are what? Tiny particles. So if they are tiny, can you see them through your naked eye? No, you can't see them through your naked eye. If you can't see them from your naked eye, can you measure them? No, you can't measure them. Why? They are so tiny and you can't even see from the naked eye. Therefore, you can't measure. Right? Now, if you are measuring an atom, right? If you are measuring an atom, is it possible? No. See me now, like you don't have a scale or something to measure the atom since they are very small. So therefore, this atom, the real mass of the atom is being compared, okay, it is being compared to a unit. It is being compared to a unit. That unit, you call it as the atomic mass unit. You call it as what? Atomic mass unit. What is atomic mass unit? You express the real weight or the real measurement of the atom through this unit. What is that unit? Atomic mass unit. Right? What is that unit? Atomic mass unit. The mass unit of an atom is being expressed by the atomic mass unit, right? That you call it as the atomic mass unit, right? Then you have to understand there is a value for this unit. If it is a unit, there should be a value, right? Then what is that value? You have to understand step by step, right? We'll go to the lesson step by step. What is that unit? That is the atomic mass unit, right? The atomic mass unit is equal to mass of 1/12 of mass of 12 carbon isotope. You know what is isotope? Isotope are the element which has the same atomic number but different mass number. One of those is carbon is as some isotope, right? So this atomic mass unit is the value of 1/12 of mass of 12 carbon isotope. Right? Now, do you have to understand relevant to this how this is happening? No. What you have to know, you have to know this. Atomic mass unit is equal to this value. Right? Now, in this session, I'm not going to just exaggerate things and teach you what is unnecessary for your exam. Right? Whatever that is necessary will be taught in this class. So, understand it in a better way. Right? The simplest form of the lesson will be taught today. Right? So, the atomic mass unit is what, children? 1/12 of mass of 12 carbon isotope, right? So this you call it as the atomic mass unit. Then what you have to know? You have to know some equation from this lesson, right? So did you all understand until now? Any doubt? Any doubts?
No, miss.
Right. So we'll continue. Give me a minute. Right. Okay. Now, from this lesson, what you have to learn next? To find the relative atomic mass. Relative atomic mass. What is relative atomic mass? Let me teach you. So, the relative atomic mass means what? Now, you have an atom, right? Relative. What is relative? Relative means, remember, you are comparing something with something, right? You are comparing two things. That you call it as relative. Now, relative atomic mass means you are comparing the real mass of atom. Real mass of an atom to the atomic mass unit. To the atomic mass unit. That you call it as the relative atomic mass. Right? Let me tell it once again. There is something called relative atomic mass. What is relative atomic mass? If you hear the word relative, you have to understand you're comparing something. Right? Relative atomic mass means you're going to compare the real mass of the atom with the atomic mass unit. Right? You're going to compare what? The real mass of the atom with the atomic mass unit. Okay. Now, for an example, you take an element. Out of that, you take an atom. You measure the weight. That you're going to compare. What is the relative? What is atomic mass unit, children? 1 How do you tell it? 1/12 of mass of carbon, 12 carbon isotope, right? So you can either write this, you can either write that. Now, let me ask a question. Are you going to solve questions with this equation? No, you don't need it, right? You don't need to solve question with this equation. Why? Already in your textbook, they have given you the relative atomic mass of the first 20 elements in the periodic table. So it is not necessary to find the relative atomic mass, right? Already it is given. They are telling you how to find it, but you're not going to use that equation, right? But you have to remember this equation. They ask you some of the questions. Okay, but they are not going to tell you to solve and get the relative atomic mass of a particular element. Okay, then what you have to remember, you have to know how to find the relative molecular mass. Now this one you have to know. This one you have to know how to find the relative molecular mass, right? Now what is a molecule, children? First of all, tell me what is a molecule. Anyone knows what is a molecule? Molecule, let me tell them, right? If you all don't know, let me tell it, right? Molecule means when you have similar or dissimilar two or more atoms together, you call it as a molecule. Okay, similar or dissimilar two or more atoms together, you call it a molecule, right? Now you take O2. Now oxygen is an atom. Oxygen is an atom. How many oxygens do you have here? You have two oxygen. When two oxygen atoms combine together, you call it as a molecule. Now O2 is an atom? No. O is atom. Oxygen is atom. O2 is a molecule. O2 is a molecule. When you take water, H2O. Okay, you take water, H2O. Hydrogen is an atom. Oxygen is an atom, right? These are dissimilar atoms. Together, you call it as a molecule, right? Did you understand what is a molecule? That is the basic idea about molecule, right? Now, relative, same idea you're going to use for relative atomic mass. Similar idea. Relative means what? You're comparing. You're going to compare what? The molecular weight, right? The real mass of a molecule, right? Your real mass of a molecule. You're going to compare that with the atomic mass unit. With the atomic mass unit. That you call it as the equation. That is the equation to find the relative molecular mass. Right? Now let me tell you. Are you going to use this equation as well to find the answers? No, you're not going to use. There is an equation to find the relative molecular mass. Relative molecular mass can be found by the addition. Okay, with the addition of relative atomic mass. Right? Understand it well. You're not going to use the above two equation in your exam to find the answer. What you have to know, to find the relative molecular mass with the addition of relative atomic mass. Let me tell you, right? Now, how a molecule is made? When you have atoms together. When you have atoms together. Now, when you take oxygen, this is an atom. When these oxygen atoms combine with another oxygen atom, it will form what? O2 gas. It will form O2. Right. Now, if you know the relative atomic mass of this oxygen, when you add the relative atomic mass of another oxygen, you can find the relative molecular mass. Right. Now, what is a relative atomic mass? You don't have to memorize the relative atomic mass, what is given in the textbook. They will give you if it is posted in a question. Right. So, the relative atomic mass of oxygen is 16. How many oxygens do you have here? You have 2 oxygen. Then 216. You add these 216. 16 plus 16 will give you 32. The relative molecular mass of oxygen 2, that means O2, is 32. Did you understand how to find the relative molecular mass? This is the one that you have to use. This is the one that you have to use. To find the relative molecular mass, you have to add the relative atomic mass. You see here, to form this O2, you need 2 oxygen. So the one oxygen's value is 60. There are 2 oxygen in this molecule. Then you add both the values. Then you will get 32. Did you understand, children, how to find the relative molecular mass? Anyone has a doubt? Anyone didn't understand? Let me know, children. Anyone has a doubt? If you have a doubt, leave it in the chat. Send it to the co-host. Please don't send it to the chat host. I will not be seeing. So make sure you are sending it to the co-host at any time. Okay, then no doubts, right? Anyone has a doubt, please be honest yourself and tell it, because here you are here to study, right? To study whatever you don't know, right? So utilize that and study now itself, children. Right. Then, with this help, shall we do some questions from the tune? Who doesn't have the tune? Who didn't receive the tune from the group? Can you all raise your hand? Can you all please raise your hand? I'll send it to you now. If you don't have the tune. Right. So children, if it is possible, can you all leave a message to my WhatsApp number? I'll send you the tune because I don't know your number. Leave a message to this number. This is my WhatsApp number. Send a message. I'll send you the tune right now. Please send the message, children. Then only I can send it back to you. Right. Now, can you please do this question? We are going to work together. You have to try a question. That is where you will feel the confidence to face a question. Now, there are some people, whenever they see a numerical expression, they get scared. They are feared about it. So that fear you should not have it, right? Feel confident to attempt a question. When you will feel confident, okay, when you will be able to feel the confidence, when you practice a lot. It's okay if you made mistake. It's okay. That is completely fine when you do wrong. When you do mistake, that's okay. But you have to learn at the end of the day. Can you all please do the first few questions? Let me tell you what are the questions that you have to do. Everyone attempt the question. It's okay if you have learned this lesson before, but that's fine, right? We are here to work, to boost your memory power and to study what you don't know. Right, can you do these questions, please? And do this fifth one as well. This is most important one. You have to know how to find the relative atomic molecular mass. Right, at the meantime, I'll send you the tute. Right. Someone messaged me, so I have sent you the tute, dear. I don't know who is that. I have sent you the tute. Check it. So do the questions, children. If you have any doubts, you didn't understand a part, ask me, I'll help you out. Right? Rasha, Rizmi, did you get the tute, dear?
Yes, teacher.
Okay. Do the question, attempt it. So this lesson is important for the MCQ. You will be needing this lesson. So that therefore try. Simple work, but if you make mistake in this, you will lose marks in the paper, right? So don't think this is easy, don't need to attempt. No, you have to try. If you have made a mistake, you can correct yourself. Do the fifth one, A, B, C. At least do till B. Then once you all are done, let me know in the chat. I will discuss the question. In the past paper class, we are done with this, but Actually, we are having a plan to do the chemistry parts once again from coming Thursday. The poster will be out soon, right? Then you can just uh, got to know, can get to know about it, right? In the past paper class, we are currently doing the lesson continuity of life, and we have just one more lesson to complete from the grade 10 syllabus, and from next month we will be starting the grade 11 syllabus. The past paper class will be happening in that way. For the grade 11, we are at the lesson of electrochemistry. We have started electrochemistry. We are halfway through that lesson. It happens on Saturday at 4 p.m. Do this question, children. Attempt it. Please don't just stay in the class, right? Be focused and do it.
Teacher, for the fifth one, the relative atomic masses are not given, right?
Yeah, I'll give it. It is not attached to the question. Wait a minute. I'll write it on the board. So, what are the relative atomic mass you all needed? Hydrogen is 1, oxygen is 16. Then, what else you need? Nitrogen is sodium is 23. Then you need for carbon. Carbon is 12. So these are the atomic mass that you need to do the question. So you don't have to worry. You don't have to memorize all these atomic numbers. The exam in the exam paper they will be giving you. Right. Are you done, children? Shall we move to the next part? If you all are done, leave a message in the chat saying that you are done or you are doing or Right. Some are doing. Okay. Some are done. We'll wait for 1 more minute, then we can discuss. Done. Okay. Done. Right. How about the others? If you all are done, let me know, children. Okay. If you all are done, let me know. Please don't send into the host. Whatever the doubt or whatever you wanted to clarify with me, send it to the co-host. No, you don't have to memorize the relative atomic mass because obviously in the paper they are going to give you, right? But when you actually start practicing certain question like oxygen, hydrogen, nitrogen is the mostly asked question. The compounds are normally what is given in your syllabus is made out of them. So therefore, when you start practicing, automatically you will memorize. Okay, so therefore you don't have to spend time and do it, right? Automatically, when you start practicing question, you will start to learn, right? So apart from that, if you even don't memorize it, you don't have to worry. You will be getting in the question paper. They will be attached in a bracket, right? If you have gone through a past paper, you can see them. Even in the MCQ, they used to give. So then, therefore, you don't have to worry. You memorize, and it's easy actually for to do the question. But anyways, that doesn't play a major role. That doesn't actually impact. You're welcome. Right. I think it's time to discuss, right? So already to talk about the atomic mass unit and everything which was written on the board, and there's nothing to do. I tell it once again. So let's directly get into the question, right? Let's do the fifth one. So look at the board. The first one is to find the relative molecular mass of water, H2O. This is a molecule and they are asking for the relative molecular mass. So to find a relative molecular mass, you have to add the relative atomic mass. Addition of relative atomic mass will give you the relative molecular mass. Now in this compound, this is a molecule. What are the atoms do you have? You have hydrogen, you have oxygen. How many hydrogen do you have? You have 2 hydrogen. You have 2 hydrogen in this molecule, right? Then 1 hydrogen value is what? 1 hydrogen's relative atomic mass is what? Oxygen's relative atomic mass is 16, right? Then you add the value. You have 2 hydrogen, you multiply by 2 and you add it with 16. How many oxygens do you have? You have 1. 1 into 2 will give you 2. 2 plus 16 will give you 18. So 18 is the relative molecular mass of water. Did you understand and did you get this answer? Did you all get this answer, children?
Yes, miss.
Very good. If you have got it, that's really great. Okay. So then let's move to the next one, right? Let's move to the next one. The next one is NH3, ammonia. The next one is NH3, which is ammonia. Right? Now, what are the atoms do you have? You have nitrogen atom and you have hydrogen atom. You have nitrogen atom and hydrogen atom. How many nitrogen atom? You have 1 nitrogen atom and 3 hydrogen atom. You have 3 atomic mass is 4. You have 1. Therefore, you multiply by 1. Then, how many hydrogen do you have? You have 3 hydrogen. 1 hydrogen is equal to 1. You have 3 hydrogen in the molecule. You multiply by 3. right? 14 into 1 is 14. 14 plus 3 is what's the value?
17.
17. 17 is the relative molecular mass of ammonia, NH3. Understood? Did you all get this answer?
Yes, Miss.
Right. Then the next one, that is sodium 2, and you have right. So sodium in this molecule, you have 2, you have 1 carbon, you have 3 oxygen. That is the ratio that is given, right? So sodium's atomic mass, sorry, relative atomic mass is 23. So 23 into 2, you have 2 sodium, then you multiply by 2 plus how many carbon do you have? You have 1 carbon, then 12 into 1 plus how many oxygens do you have? You have 3. Then when you solve it, how much will you get?
106.
How much will you get? Give me a minute. One second, children. Child is calling me continuously. 1 minute. I'm sorry. So the answer is 108. The answer should be 108. Did you all get this value, children? So this is how you find the relative molecular mass, right? So if you are done with this, you are feeling comfortable to answer this question, that is great, right? So this is one of the basic things that you have to know out of this lesson. Okay. Then let's start talking about the next topic. Do you have any doubt? Do you have any doubts, children, relevant to what did we study so far?
No, teacher.
Okay. So we'll continue with the next one. Okay. So now we are going to talk about
Excuse me, teacher.
something. Sorry.
I have doubt in second and third question. Sorry,
Second,
third and fourth questions.
third, and the fourth. This and this.
No. The paper, third and fourth.
Main one. Okay. Give me a minute. This is okay. Wait. Third and the fourth, right? What is that question? So you write the equation. What is the equation to find the relative atomic mass? Relative atomic mass is equal to the real mass of the atom over. This is what you have to write. Whatever I wrote it before. Relative atomic mass equals real mass of atom over atomic mass unit. Instead of this atomic mass unit, you can write the mass of 1/12 of mass of 12 carbon isotope. That is also fine. Right? Similarly, you write it for relative molecular mass. This is what they're asking for. Real mass of molecule. Here you're going to compare the molecule. Then you talk about the molecule over the atomic mass unit. I'll write as mu. Then the next one they're asking for the other way to find the relative molecular mass. Relative molecular mass is equal to the addition of relative atomic mass. That is a method that you use. That is the one that they are expecting you to do. Not this two. You don't have to do them. What is an atomic mass unit? Atomic mass unit is the unit expressed. You can tell it in this way as well. It is the unit which is used to express the real atomic mass. Okay. It is a mass unit which is used to express the relative real atomic mass. That is the one you have to write. Okay. Right. Then let's continue with the next one. Then you have to know something called molar mass, right? You have to know something called molar mass, right? So there is a comparison that you have to understand between these two, right? Now, right. So molar mass. Molar mass is something that is equal. You can see. Molar mass is something that is equal to the relative atomic mass or to the relative molecular mass, right? Now, when you take sodium, which is an atom, right, the relative atomic mass is 23. Therefore, the molar mass of sodium also will be 23. The only difference where you can find between them is the unit. The only difference that you can find between the molar mass and the relative atomic mass or the relative molecular mass. Now, when you consider sodium, the relative atomic mass, it is an atom, therefore it is 23. Here is also going to be 23. But the only difference is molar mass has a unit. Molar mass has a unit. That unit is gram per mole. Gram per mole. Then what you have to understand, relative atomic mass and relative molecular mass does not have a unit. They don't have a unit. If just that numerical value is given, that is a relative atomic mass or the relative molecular mass, with the unit is given, that is going to be the molar mass. Now when you take for water, H2O, which is 80, the molar mass is 18 gram per mole. But the similar value for the relative molecular mass, which is 80. Did you understand what is the only difference that you can find between the molar mass and the relative atomic mass or the relative molecular mass? The unit. Molar mass has a unit, while the relative atomic mass or the relative molecular mass does not have a unit. Understood the difference?
Yes, miss.
Right. Then you have to know something called the Avogadro's constant. What is that? Avogadro's constant. Right. Now, what does he say? He is a scientist. I'm not just going to talk in detail, but the main idea to understand the lesson well, let me teach that part. Okay. Now, when you take an atom, right? You take an atom. Let me take it as sodium atom. Right? Let me take it as a sodium. What is the relative atomic mass of sodium? Come on, children, answer my question. What is the relative atomic mass of sodium?
23.
23.
Very good. It is 23. Now, this 23 is equal to the Avogadro's constant. This 23 is equal to the Avogadro's constant. Avogadro's constant has a value. Avogadro's constant has a value. What is that value? 6.022 10 to the power 23. Right? 23 sodium atom, it is the relative atomic mass. That 23 is equal to the Avogadro's constant. That is one idea you have to remember under Avogadro's constant. The next one, you take a molecule, right? Let's take it as a water molecule, which is 18. The relative molecular mass is 18. This 18 is also equal to the Avogadro's constant, which is 6.022 10 to the power 23. Did you understand? This is the only thing that you have to understand. Literally, children confused with this part. What you have to understand, if it is a relative atomic mass or a relative molecular mass of a particular substance, that is equal to the Avogadro's constant. What is the value of Avogadro's constant? 6.022 10 to the power 23. That is the only thing that you have to study. Nothing else, nothing to worry about anything else. This is the only thing. Right? Therefore, you can come up with the idea relative atomic mass or the relative molecular mass is equal to the Avogadro's constant. It is equal to the Avogadro's constant. Understood the idea?
Yes.
Anyone has a doubt? Anyone didn't understand? Right. So then let's move to the next part. Then you have something called mole. Mole is also something relevant to this. Mole is also something relevant to this. Now you have this 23, right? Right? You have the relative atomic mass as 23, which is sodium. Right? This 23 will be equal to 1 mole. This 23 will be equal to 1 mole. Similarly, this 18 of this molecule will be equal to 1 mole. That means at the end of the day, what you have to understand, relative atomic mass or the relative molecular mass will be equal to Avogadro's constant. Then equal to what? Equal to mole. Equal to mole. This is the idea that you have to understand at the end of the day. What is that? Relative atomic mass or the relative molecular mass is equal to the Avogadro's constant. What I showed here. Then you have to understand which is equal to the mole. Which is equal to 1 mole. This 23, which is the relative atomic mass of sodium, is equal to 1 mole. Right? The relative atomic mass of water, relative molecular mass of water is 18, which is equal to 1 mole, and it is equal to the Avogadro's constant. Got the idea? Got the idea, children? Any doubts?
No.
Right. So if you all have a doubt, leave it in the chat. I'll tell it you once the explanation is done. Right. I'll tell it once again, Willow. Now you have an atom. Right? That atom's relative atomic mass is 23. You have the sodium atom, which is equals to 23. Now, as I told you, this 23 will be equal to the Avogadro's constant. This 23 will be equal to the Avogadro's constant. That is the atom. Right? 23 relative atomic mass is equal to 6.022 10 to the power 23 atom. That is the idea that you have to understand. Right? Then you have to understand this 23 is equal to 1 mole. This 23 is equal to 1 mole. Right? Then what you have to understand, the similar idea which will be applicable for relative molecular mass as well. What is that? When you have a water molecule, which is the 18, which is the relative molecular mass, that is equal to the Avogadro's constant. That is equal to the Avogadro's constant. That means 6.022 to 10 to the power 23 molecules are present in this 18 relative atomic mass, relative molecular mass. Then what you have to understand, this 18 is equal to 1 mole. This 18 is equal to 1 mole. That is the idea you have to understand. If you feel that is hard to understand, can you please write this part? When you see this, you will understand. Relative atomic mass or relative molecular mass is equal to Avogadro's constant and for 1 mole. Write this down if you need it. If you all want, you all can write whatever I write it on the board, okay? Right. Barakallah. Okay. So then let's move to the next part. Let's move to the next part. Right. Then in this part of the lesson, the most important thing and the most expected question is this. There are two main equations where you have to study. Right? There are two main equations where you have to study. The first one, to find the number of moles. To find the number of moles present in a given mass. Okay, to find the number of moles present in a given mass. Right. So that equation is number of moles equal mass over molar mass. Number of moles equal to mass over molar mass will give you the number of moles. This is mass. Simple M is mass. Capital M is molar mass. Right. Okay. Now this is the most important equation. Put a star and write it in a red pen or whatever which can be highlighted. This is the most important equation in chemistry. This will be connected when you move to grade 11. If you are a grade 11 student, under the lesson mixtures, this part of the equation is important, right? So this is like a basic equation that you should know to do a chemistry question, right? So this one is most important one. Write it in a dark color pen and make sure you are not forgetting this equation. Okay, now let's do some question out of this actually, right? So let me check, do we have in the tute? Give me a minute. Okay, we'll do this. Right, now for example, I'm going to take ammonia. Right, I'm going to take ammonia. Ammonia is a molecule, right? The gram of ammonia, there is 8.5 gram of ammonia, right? Then I'm asking you to find the number of moles present in this mass. Find the number of moles present in 8.5 gram of ammonia. Right. Now what do you have to do? Simply you have to follow this equation. Simply you have to follow this equation. What is the equation? You are going to find the number of moles. What is the mass given in the question? 8.5 grams. You always write with the unit for the first time. When you are substituting to an equation for the first time, you are going to write it with the unit. If not, marks will be cut off. Right? Then you have to find the molar mass. Now, finding molar mass is easy. What is molar mass? Molar mass is equal. Molar mass is equal to the relative atomic mass and the relative molecular mass. Now, this is a molecule. When you get the molecular weight, relative molecular mass of ammonia, that is equal. When you add the unit, gram per mole, that is going to be the molar mass. Simple idea, right? Now, similarly, which I did for water. 18 is a relative molecular mass. The molar mass is 18 gram per mole. Understood the logic? The similar idea you're going to apply here. Now you're going to find the molar mass. That means you're going to find the relative molecular mass and add the unit for molar mass. Simple idea, right? You have, now if I write it here, NH3, 1 nitrogen, 3 hydrogen. 1 nitrogen and 3 hydrogen. What is the relative atomic mass of nitrogen? It is 14. 14 into 1 plus, you have hydrogen. How do you get the hydrogen? You have 3 hydrogen. Hydrogen relative atomic mass is 1. Then you multiply by 3. Then you will get the value. 14 plus 3 is 17. 14 plus 3 is 17. Right? Then you got the relative molecular mass. To this value, you are going to add the unit gram per mole. You are going to add the unit gram per mole. Then this is the molar mass. You found the molar mass. Did you all understand how to find the molar mass? Having any difficulties to find it, children?
No, miss.
Right, great. Right? Then you write 17 gram per mole. Gram per mole. Then what you do? You can first of all cut off these two similar units. You can cancel off, right? Then 8.5 divided by 17. Now you should be like average student in maths to do the calculation first. Come on. What will be the answer? You divide 8.5 by 17.
0.5.
Very good. Good job. Which is 0.5. Now, mole per. When you take this per up, it will become mole. It will become mole, right? So then the number of mole present in 8.5 gram of ammonium is 0.5 mole. Did you understand?
Yes, Miss.
Yes, Miss.
So if you have a doubt, let me tell it once again. Listen carefully, right? Now this is the equation that you're going to find the number of moles, right? Now this is a question that I gave you. You have ammonia, 8.5 gram of ammonia. Then I'm saying you to find the number of mole present in this 8.5 gram of ammonia. That is a question that I'm asking for. Then you substitute the value to this equation, right? You know the mass. You know the molar mass, you substitute, you divide it, then you will get the number of mole present in the molecule. Did you understand? Okay. Let's move to the next one. Now we are going to talk about the next important equation. Before that, shall we do some question and come from the tune? Then it will be more easy. So understand the concept. This is the concept that you have to understand. This is what I told you. You understand how it works. Therefore, you can apply in any question where they ask for. That is the understanding ability that you have to have when you study chemistry. That's the only thing that you have to know. Nothing else. Give me a minute. I will share the screen. If anyone joined new and you all don't have the tune, right? Send a message in WhatsApp. I'll send you the tune. Right. So can you all do this question, children? Start doing it below. Do the question. We stopped here, right? Do from 6th one till 8th one B. Right? Do this. Try it on your own. It's okay if you even if you get wrong. Attempt is a must. I'm not saying you have to get the 100% correct answer. No, you have to attempt. When you attempt several times, obviously at once you will get it correct. That is called learning. Not just sitting for hours reading the book is known as learning. You learn from your mistake, and where you don't repeat it, that process you call it as learning. Right? Do it, children. Everyone has to attempt the question. Even if you don't know, just look at the screen, look at the board. I have given the equation. You can use it and somewhat find the answer. Once you all are done, leave a message in the chat. Then we can get the count and do the rest. So magnesium is equal to 24. Okay, the relative atomic mass of magnesium is 24. Then I'll give it here as well for carbon. Not for carbon, that is here. Calcium is 40. Then the remaining, you know, let me write it properly. Calcium is equals to 40. Magnesium is equal to 24. Then what is 61? Carbon is equal to 12. Oxygen is equal to 60. These are the values that you need to do the question. Yep, you have to do the 9th one. You have to do this as well. That's the most important one. Others were just for your idea, but this is the actual practice. Do it, children. Once you all are done, let me know. Attempt the question. These are simple ones. Everything is given. Just use the equation to find it. That's the only thing that you have to do. Nothing else.
For the
Right. Some of the
9B question, don't we need the mass?
Oh, I have not given the mass. Right. Give me a minute. I'll give you the mass. The mass is supposed to be take it as 300. Take the mass over here for this question as 300 gram of calcium carbonate is used. 300. Okay. I'm sorry, I didn't notice that. Do it, children. We'll discuss in 2 minutes. Right. I think the time is enough. Shall we discuss? Most of the children are done. Good job. I really appreciate your try. Your attempt is appreciated. Even though you don't get the correct answer, that's okay. The attempt is important, not the correct one. But getting a correct one is perfect. Okay. So we'll discuss the question, right? Okay. So already where you have to write the equation and those stuffs, right? So let me directly get into the question, the 9th question. So then we can discuss that. Right. So if you need the answers for the previous question, let me know. I'll tell. But then we'll start doing the 12th one. So not the 12th, the 10th one, 9th one. Okay. Right. So the first one, the A question says that find the number of moles present in 12 gram of magnesium. 12 gram of magnesium. Right. Now what is the equation that you're going to use to find the moles? Number of moles equal to mass over molar mass. This is the equation that you have to use, right? Mass is 12 gram. You write it with the unit. The molar mass of magnesium. There's only one magnesium atom. The relative atomic mass is 24. then you write it as 24 gram per mole. This is what you have to write. Okay. Then gram and gram you can cancel off. 12 and 24 you can cancel it. Then what will you get it?
0.5 mole.
You will get it 0.5. Right? You will get it as 0.5. Okay. So 0.5 moles is the answer. The number of moles present in 12 gram of magnesium. Understood, children?
Yes, Miss.
Okay. Then we'll move to the next question, that is calcium carbonate. So 300 gram of calcium carbonate is used. Calcium carbonate, right? To find out, first of all, let's find the molar mass. Calcium is 40. 40 into 1 will give you 40 plus carbon. You have 1 carbon, which is 12. 12 into 1. Then you have 3 oxygen, which is 16 into 3. Then it is 46. Then 12 plus 40. What is the value? 100. Give me a minute. One minute, children. There is a connection issue. 1 minute. 1 minute. Right. Okay. Right. So you will get. It should be 48. Okay, not 46. Should be 48. Right. Then you will get 100. 100 moles is the answer. Number of moles present in 300 gram, which is 100. Understood? $24 gram per mole. Is that for this one? You know that now magnesium is, there's only one magnesium, right? Then one magnesium is the relative atomic mass. This is just an atom, right? When you have a combination of 2 or more atoms, you call it as a molecule, right? Now relative atomic mass of magnesium is 24. It is already given in the book. You don't have to memorize or study related to that, okay? So 24 is a relative atomic mass. So you know that the relative atomic mass equal to molar mass, right? The only difference is, which as I told you, the unit. Relative atomic mass or relative molecular mass does not have a unit, while molar mass has a unit, which is gram per mole. Then 24 gram per mole as we got. Understood?
Excuse me, teacher.
Yes.
For that second question, E part, the ninth one, we should divide, no? From the mass, the molar mass.
Yep. Wait. I'll come. So this is the number of moles. Wait. Not the moles, actually the molar mass. Wait. Okay. So this is the number of molar mass. Okay. That is gram per mole, right? Then you have 300 gram to find the number of moles, which is 100 gram per mole, which is the molar mass. Then you divide it, cut off the gram and gram. Then you have 300 divided by 100 is 3. Then you have per mole. You convert it to up. Then it is mole. 3 mole. Okay. Understood?
Yes, Miss.
Right. Anyone has a doubt? No, right? So far it is clear, right? So actually what you have to do is you have to remember the equation, number of moles equal mass divided by molar mass. If you remember that equation, you have to just substitute the value and find the answer. That is it. right? Not that difficult. Okay, then now let me teach you about the next important equation of this lesson, right? This is one. The next one, let me teach you now. That equation you can use to find three things, okay? The second main equation you can use to find three things. What are those? To find the number of atoms. Okay, to find the number of atoms. Number of molecules and number of ion present in a substance, right? So that equation, the equation which I'm going to teach you, you can use that to find the number of atom present, number of molecules, number of ions, right? So that is number of moles into Avogadro's constant. Now tell me, what is the value for Avogadro's constant, children?
6.022
Anyone?
10 to the power 20.
Very good. 6.2022 10 to the power 23. Now, this is the equation, the second most important equation where you have to remember out of this lesson, right? What is that? Number of moles into Avogadro's constant, right? Now, for example, let me take it as, you're going to take water, right? 180 gram of water. Right, 180 gram of water. Then I am telling you to find the number of molecules present in the 180 gram of water. Right, find the number of molecule present in 180 gram of water. Right, this is the question that I am asking for. Right, then you write the equation. Ne into 6.022 10 to the power 23. Right. Now, what is this N, number of mole? If you elaborate and write it, that is mass over molar mass. They haven't given you the number of moles, then you have to find it. How do you find it? When you divide the mass over molar mass, you will get the number of moles. Then you multiply that with 6.022 10 to the power 23. Children, whenever you are substituting to an equation, go step by step. Right? First, you write the equation. Then you substitute each and every value. Then you get the final answer. So that is where you will get the complete marks. Then you know that. Do you know that when you get a question relevant to an equation, then they are asking to solve the equation with that equation, means solve the question with that equation, then you will get 3 marks. Why? One, when you write the equation, right? First one mark you will get when you write the equation. The next 1 mark you will get for substitution, and the third mark you will get it for the final answer. So if you don't write this, now imagine you skip the method, skip the solving part, you will get reduct of 1 mark. Right? If you didn't write the equation, you will get reduct of 2 marks. Then you will get only 1 mark at the end of the day. Right? So therefore, write it step by step where the examiner can understand what you have wrote. Okay? Now, let's get back to the question. What is the mass? 180 gram. What is the molar mass of water? You already know, we have already done so many times. The relative molecular mass is 18. Then if you add the molar mass unit, which is gram per mole, which is going to be the molar mass. That is 18 gram per mole. Right, into the Avogadro's constant, 6.022 10 to the power 23. Okay, then gram and gram you can cancel. 180 and 18, how many you have? You have 10. Right, you have 10. In 180, how many 18s are there? You have 10. Right, so if you have a 10, then you have a power, you can give that to the power. That means this will be get reducted and your final answer will be 6.022 10 to the power 24. This 10 will be given to here, which will be turned to 24. This is simple maths, right? So this is how you find it, right? What you have to understand at the end of the day, you use the equation according to their given idea. Whatever the question that they have given, you just implement all the substitute all the value to the equation, then you get the final answer. That is the only thing. That is what I told you at the beginning as concept. You have to understand the concept. What is the concept? This is the concept. How to do the concept? You add it to all the question. That is the only thing that you have to understand. You don't have to memorize anything unless the equation from this lesson. Right? So that is how to study chemistry easy. Okay, that is the only method to study chemistry. You don't have to memorize anything in chemistry. It's not like bio. Right? You have to understand how it works and then you apply for the question. Right? Okay, we'll do more question. You will understand when I do question, right? We'll do another one. This question is the next one in your tute. You have to do it, right? So listen once again, Milo, then I'll explain this one itself. You are going to use this equation. Let me write it from the beginning. If not, it would be confusing. Listen, if you all didn't understand, listen here, children. Look at the board, concentrate, okay? Now, they have given you a question. 180 grams of water. 180 grams of water. Find the number of molecules present in this 180 grams. Right? That is a question that they are asking you. Okay. Now, to find that, you're going to use the equation. What is the equation? N into Avogadro's constant. That is 6.022 10 to the power 23. Right? This is what you have to use. Right? How do you get this N? When you elaborate and write it, that is mass over molar mass. Do they have given you the number of moles? No. Then you have to find it. To find that, you need the mass over the molar mass. Okay. Then you multiply that with 6.022 10 to the power 23. Right? What is the mass? 180 grams. What is the molar mass? You are going to find. Now, so many questions we have done and we were taking the example as water molecule. Then we know that it is 80. If it is a molar mass, then you add the unit. 18 gram per mole. That is the unit, right? Then you multiply this with the Avogadro's constant 6.022 10 to the power 23. Right? Then gram and gram you can cancel off. In 180 you have 1080. Then you can simplify and get it as 10. When you get here 10, when it is multiplying with a power, then you can change it and write it as 6.022 10 to the power 24. Did you understand? This is simple maths, right? You have to know these certain stuffs to do the question. Understood? This can happen only when you have 10 here, no any other values, right? If you have 2, you have to ultimately multiply this value. We'll do more questions, then you will understand. Right. Did you understand, children? Got it? Anyone has a doubt, let me know. If anyone has a doubt, let me know.
No doubts, teacher.
No. They don't have any unit. You just have to mention it as molecule. They are asking for number of molecule present in 180 gram. Right? Then you have to say 6.022 10 to the power 23 molecule is present. Number of molecule is present. That's the thing. If they're talking about atoms, you tell it. 6.022 10 to the power 24 number of atoms. Ions means you write it as ion. But the question they ask for, you write it. Okay. Right. Shima, I'll do more questions and you will understand. Right? For now, do this part below. I'll do more questions in a while, then you will understand better. Instead of doing the same question again and again, if I do another one, you will understand. Can you try these 2 questions, children? I'll explain you all too. Once again, I'll do it. First of all, you all try. Use the equation, multiply the value that they have given and do it. Do the 11th. Have I shared the screen actually? No, right? Yes. Wait. Share it. Do the question number 11 and 12. Do question number 11 and 12. Right? So this is the question which I have given on the board, which I discussed. Right? Do it on your own, children. Right? Do it on your own. Repeat when you are writing. Whenever you write the equation, say it aloud. N into 6.0 2 to 10 to the power 20. See, you write when you write each and every number, you express through your mouth. You tell it aloud. Then it will be stored better. Do it, children. Do it. Try both the question. Both are easy, not hard. Use the same method. Then you will find easy. Shima, try the second one. You will understand. Right? When you have this 10, only this power will change. Right? Otherwise, no. If you have 2, you multiply this one. You don't have to multiply the 10 to the power 23. Right? You just keep it aside. You multiply this 6.022 only. Not that complex question is given. If there is another number, then you have to just multiply the 6.022 only, right? So that is what you have to do in the 12th question. Do it, children. Try it out. Then we'll discuss. Once you all are done, let me know. So once the class is over, if possible, send a feedback to my number. So if there is any changes to be done in the next free session, we will be considering about it. So send a feedback to this number which I'm writing on the board. Note this down, and it would be a great help if you send a feedback. And we will be developing with your concern, like whatever you wanted and how was it, was everything fine? So just let me know what you think about this class, then we can overcome that. Class will be finished when this part is done. Once we discuss this part, the class is over. That's all for the thing that you have to understand. Carbon, the relative atomic mass is 12. Carbon's relative atomic mass is 12. I'm sorry, I just forgot to attach it in the tube itself. Try it, children. Keep doing the question. And send me your answers in the chat, then I can just send me the final answer. Then I can see whether you all have done the correct one. It's okay, your attempt is important. That's it. You can send it in the Zoom chat. If you all are done, just send it, then I can check whether you have done it correctly or wrong. Fatima Absai, the answer which you have sent, is it for which one, dear? Second one? Yeah, I mean the 12th one, yeah. Can you check with the 10 to the power, what's the power that you have given? Check with that. Hana Fauzan, the 11th one is correct. Very good. Good job. No,
Miss,
not exactly. Yes.
if we didn't get 10, what should we do?
Sorry.
The answer of the number of molecule is not 10.
I couldn't hear you, dear. Send me in the chat, then I can reply to you. Children, you can't change the power, right? Should be 24. When you multiply, you don't have to change it. Unless you have it 10, you can't change it to 24. Hannah, Fauzan, check your answer for the 12th one which you have sent. Ahmad, Irfan, have you sent it for the which question? Is it for the 12th one? Fatima Afsa, your answer is correct. Very good. For which one, Shima, you have sent your answer, dear? Zainab, Zia, your answer is correct. For the 12th one, good job. Then who else? So Shima, have you given for the first one as 1.6 or is it 6.0? So you have given 2 dots. So it's confusing. Okay, okay. Then the answer is correct. Second one is nope. Second one, check it. Shima, check your answer for the second one. Abhishant, your answer is correct, dear. Very good. Who else? Yeah, you don't have to multiply the 10 to the power 23. Multiply that 6.022 only. You don't have to multiply the other one, right? So they don't ask for their complex calculation. Is it 24, Shima, the first one that you have given? Or is it 4? No, you don't have to. You don't have to change the power. They don't ask for that complicated one. Just do the first one. 24 means, Shima, your answer is 24 into... No, Shima, it's not that value. Check, check. Wait, I'm slowly reading one by one. No, you don't have to use that sort of a calculation over here. If you do the basic one, that is enough. You don't have to change the power. Don't go and do the advanced one and finally end up with the wrong. So if you send it to me in WhatsApp, give me some time. I'll check. Selena has sent to me in WhatsApp. I'll check. Give me some time. The power that you have to change when you have only 10, right? The question that we did something like this. Then if you change it, that is fine. Other than that, please don't go to change the value over there. Sarah Muhammad, your answer is correct. Very good. Now let me come to WhatsApp. Few of the students have sent it to me in WhatsApp. I'll check. Oh my goodness. How many messages I have got? Okay. Give me a minute. Ibrahim, check your answer. It is not that. No. Check it. Selena, multiply it by 4. Okay, multiply that 6.022 by 4. So that is going to be the final answer. Right. So shall we discuss? I hope that you all have done. Everyone has done the work. So we'll discuss now. So Rasha, check your answer. Okay. We'll discuss. The first one is already discussed, right? So I don't have to teach once again. It is given already in the board, right? Now consider the 12th one. The 11th one will not be discussed. I have already done it. Right? If you have a doubt, once the class is over, talk to me. I'll help you out. Right. Now what are they saying? Find the number of atoms present in 48 gram of carbon. Find the number of atoms present in 48 gram of carbon. Right? 48 gram of carbon. And they are telling you to find the number of atoms. Right? Let me stop sharing. Okay. So this is the question that they are asking for. Now what is the equation that you have to use? N into Avogadro's constant. 6.022 10 to the power 23. Right. What is N? If you exaggerate and write it, mass over molar mass into 6.022 10 to the power 23. What is the mass? 48 gram. What is the molar mass? You know, carbon, right? Carbon is an atom. Carbon is an atom. What is the relative atomic mass of carbon? It is 12, right? You know that relative atomic mass is equal to molar mass. Relative atomic mass is equal to molar mass. Then what you have to do? Addition to this value, you have to add the unit, gram per mole. That's the only thing that you have to do, right? Then you write that 12 gram per mole, right? Gram and gram, before that, you continue writing the Avogadro's constant, right? Then what do? You simplify. Gram and gram cancel. 48 and 12, there are 2. Then what do, children? You multiply by here. You multiply by here. Then what will you get? Not 2, 4. I'm sorry, it's 4, right? Then what do? You multiply. What are you going to multiply here? You are supposed to multiply only this value. You don't have to consider about this. Don't change that because they don't expect you to do this complex calculation. Mostly now, you might think actually, let me tell that point once. You might think what's the calculation you do is the complex one. But you will understand when you move to A level. If you have an idea to do maths or science stream in A level, you will understand that is the complex one. What you learn is something like this. But I make it on the board. Right? This is the part, this is the type of calculation that you do here. This is not complicated actually. And actually they don't expect you to do the complex calculation. The simple one, in a shorter way, that is enough. They don't ask for big pages. Just what you know, you substitute the value for that equation and you write the final answer. Right? So then you multiply this value. 4 into 2 will give you 8. 4 into 2, 8. 4 into 0 is 0. 4 into 6 is 24. Then you add the power. This is the answer. If you have got this answer, perfect, right? But if you didn't get it, did you understand the people who did not get this answer? How to get this answer? Did you understand that point? If you have understood that, perfect, right? It's okay to make mistake, as I told you. You attempt it, that is the important one. You attempt, that is important, right? The next time when you do this question, you will have a better idea. That is the only thing that I need at the end of the class. Right? Understood, children?
Yes.
This is not hard. This lesson is not hard as you people think, right? But even most of the people, whenever I ask, what is the hardest lesson that you want me to do as a session, they tell us this lesson. This is not hard. Understand the basic concept, that is enough. Yeah, Ibrahim, there was a small calculation error. That's okay. That's fine. The attempt is important, right? Now, that is all that you have to know from this lesson. Did you understand? Do you have a better idea from the time you came to the class and the end of the class? Do you have the same level or have you improved? Have you improved your... So that is the only thing that I need. The improvement should be there, right? So let's revise it once again before we leave. Let's revise it, children. Very good. I'm really happy if you have improved yourself. Great. The power you have to change if it is only 10. Remember as that. If the power, if it is given as 10 here, then you change the power as 24. Other than that, please don't keep your hand in the power. Don't touch it. Right? Then you will, for sure, you will be confused how to do the calculation. That is the advanced one that you are trying to do. You don't have to do that because they don't expect you to do it. Then why waste of energy? You don't have to try. Okay? So let's revise it quickly, whatever we studied for today. Now you are going to tell me, right? What's the first thing that we studied? We studied about the atomic mass unit. Okay? Atomic mass unit, right? And you know what is atomic mass unit? What is the atomic mass unit? 1/12 of mass of 12 carbon isotope. Very good. Make sure you are not forgetting what you learned today. Okay. Then what did we study, children? We studied about relative atomic mass. What is relative atomic mass? Where you are going to compare the relative. Where you are going to compare the atomic mass, the mass of the atom, to a unit, to the atomic mass unit, right? That is the only thing that you have to know. The real mass, okay, the real mass of atom to the atomic mass unit. I write as AMU, atomic mass unit, okay? Then you studied about the relative molecular mass. How do you find the relative molecular mass? Simple way. Here is for the atom, here for the molecule, here for the molecule, right? Then
Ma'am,
we might
atomic
write it by the relative atomic unit, right? Not relative atomic unit, atomic mass unit. Then what do you do? As the next, what did we study? We studied the relationship, the differences between the molar mass. Okay, we studied the differences between the molar mass and the relative atomic mass unit and the relative molecular mass. What is that? Relative molecular mass has a unit that is gram per mole, and relative atomic mass or the relative molecular mass does not have a unit. That is the only difference that they have, but the values are same, right? What else did we study? We studied about the Avogadro's constant. We studied about the Avogadro's constant, right? Avogadro's constant is equal to the relative atomic mass or the relative molecular mass. This Avogadro's constant or the relative atomic mass or the relative molecular mass equal to mole. Is equal to mole. Then what did we study? We studied about two main equations. What are those two? Number of moles equal mass over molar mass. This is one equation. And the second one is we studied number of moles into Avogadro's constant. 6.022 10 to the power 23. Understood? This is the end of the lesson. This is the complete idea you need from this lesson to do a question. Clear? Any doubt? Any doubt of any step?
What is atomic mass unit?
Atomic mass unit is now it is the mass unit where you compare the real mass of an atom or real mass of a molecule. You compare to a unit. That unit is the relative atomic mass. That is 1/12 of mass of 12 carbon isotope. So this is that. There is nothing to solve in this or nothing to do with that. You have to know only that. That is it. Right? Clear, children? Anything to be clarified? Right. So if possible, send me a feedback of the lesson we discussed today. I'll add my number over here. Right? Send a message of the how was the class. Send a message to this WhatsApp number. So we can bring forward many lessons such as like this, right? And if anyone is interested to join the class, which is we are doing it, so if anyone is willing to join, you can contact this number. I'll send you the details. So apart from all that, the lesson is 100% clear for you all.
Yes, teacher.
Yes.
Great. So then there's a time to end the session. If anyone has a doubt while discussing any question while you're practicing, leave a message to my WhatsApp number. I'll help you out, right? At any time, always I'm there to help, right? Don't hesitate to message and ask, right? If you have doubt related to science, ask me. I'll help you out at any time. Okay? So that's all for today. I hope you all enjoyed and gained the benefit, right? So then, thank you so much for joining. Take care, children. Bye. See you in the next free session. You're welcome.
Thank you, teacher.
You're welcome, dear.